Welcome to Convert to Radians, a Pemberton Pre-Calculus podcast, Episode 2. In this episode, we will take a look at your traditional SohCahToa triangles, where we're figuring out the sides and angles of a right triangle. We will also take a look at decimal degrees and degrees, minutes, and seconds as a means of writing a degree. And then we will wrap up with going beyond 0 to 360 degrees when we're figuring out our 6 trig functions. This is episode 2.
Let's take a look at how to solve right triangles. Most of you will remember the acronym SohCahToa to help you remember how to find the sine, cosine, or tangent in a right triangle. Let's take, for example, this triangle. Notice it's a right triangle by the right angle symbol, where angle C is located. We know that angle A is 20 degrees, and we know the length of the hypotenuse of this triangle, AB, is 12. The problem is asking us to figure out how long are the sides marked with X, Y, and also the measure of angle B. Let's begin by trying to find the value for X. One of our trig functions that we know is the sine of an angle. We know that the sine of an angle is equal to the opposite side divided by the hypotenuse. In our right triangle, we have a 20-degree angle, which we can look at the side that is opposite of it and the hypotenuse of the triangle and come up with sine of 20 degrees is equal to x divided by 12. Because in our triangle, the 20-degree angle has a side opposite of it of x and a hypotenuse of 12. To solve this equation, we want to isolate the x and therefore multiply both sides by 12 to get the x by itself. By multiplying both sides by 12, the 12s will cancel each other out, leaving x by itself. And then on our calculator in degree mode, we can calculate 12 times sine of 20 degrees and get that it is 4.10. To find y, we're going to use the cosine function. We know that cosine is adjacent over hypotenuse. So here we have the cosine of an angle is equal to the adjacent side divided by the hypotenuse. The cosine of the 20-degree angle is equal to y divided by 12. Because in our triangle, the cosine of the 20-degree angle is the adjacent side, y, divided by the hypotenuse, 12. Cosine of 20 equals y over 12 can be solved for y by multiplying both sides by 12. Multiplying by 12 on this side cancels the 12s, leaving the y by itself. On the other side, multiplying by 12 gives us 12 times cosine of 20 degrees, which on a calculator in degree mode is 11.28. The final component to the problem is finding the measure of angle B, which from geometry we know that triangles, if you add the angles of the interior together, will have a sum of 180 degrees. the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180. Angle A was 20 degrees and angle C was 90 degrees in our diagram. So angle B, by adding the 20 and the 90 together to get 110, angle B plus 110 degrees must equal 180. By subtracting 180 degrees on both sides, the measure of angle B is 70 degrees. Here is another example where this time we do not know either of the two acute angles, angles A and B, inside a right triangle. To find the x and the theta variables for this triangle, first we will start by finding x, taking advantage of the Pythagorean theorem, because in a right triangle, a squared plus b squared is equal to c squared. If we allow x to represent a and 7 to represent b, the hypotenuse 15 must represent c, as in a right triangle, the c is always the hypotenuse. By plugging in the numbers and solving, we get the following result. The square root of 176 is 13.27 if you round it to the nearest hundredths. Coming back to our problem, whenever we need to find an angle, we will still use our sine, cosine, and tangent functions, but in order to find an angle, we will eventually need to take advantage of the inverses of those functions. For this problem, notice that I know two of the sides of the right triangle, 7 and 15. From the angle's perspective, the angle theta, 7 is the adjacent side and 15 is the hypotenuse. And so, the trig function that allows me to put the adjacent and hypotenuse sides together is cosine. Cosine of my theta angle is the adjacent over the hypotenuse sides, which would give me the equation cosine theta equals 7 divided by 15. To solve this equation, we will take the inverse of cosine on both sides of the equation. By taking the inverse cosine on the left-hand side and the right-hand side, the cosine inverse and cosine will cancel each other out, leaving the angle theta by itself. However, on the right-hand side, we must evaluate cosine inverse of 7 divided by 15. On your calculator, the inverse cosine on a TI-83 and 84 is usually found by taking the second key and then cosine to get cosine to the -1. When you enter this on a calculator, if your calculator is in degree mode, you should get an angle of 62.18 degrees. I am standing outside of the new front office of MedHigh, and using the GPS on my phone, I have discovered that the latitude of where our school is located is 26 degrees, 9 minutes, and 4 seconds. So let's take a look at how do you change this into a decimal degree. In order to convert from degrees, minutes, and seconds into decimal degrees, we would take the 26 degrees and then we're going to add the minutes onto it. Now there are 60 minutes in 1 degree, and so 9 minutes can be expressed as 9 out of 60, and then the seconds are 4 seconds, which there are 3,600 seconds in 1 degree. By adding these together, the 26 degrees, the 9 out of 60 minutes, and the 4 out of 3600 seconds, the fractions will combine together to make 26.151 degrees in decimal degrees. We also can locate ourselves by longitude, where our school is currently located at 97.939 degrees west longitude, expressed in decimal degrees. Let's learn how to convert from decimal degrees back into degrees, minutes, and seconds. At 97.939 degrees west longitude, we want to convert this over into degrees, minutes, and seconds. The 97 represents the number of degrees. However, the decimal 0.939 needs to be converted over into minutes and then into seconds. So we take the decimal 0.939, and since there are 60 minutes in 1 degree, we multiply the decimal by 60 to get 56.367 minutes. So we take the 56 and express that as minutes, and then the decimal portion, the 0.367, we want to express in seconds. And since there are 60 seconds in 1 minute, by multiplying 0.367 times 60, we get 22.02 seconds. So our school's location, west longitude, is 97 degrees, 56 minutes, 22 seconds in decimal, converting from decimal degrees to degrees, minutes, and seconds. Calculating the exact values of the trig functions beyond 0 to 360. Let's say we wanted to find the sine of a 405 degree angle. The first thing we need to do is we need to try to figure out what angle is coterminal with 405 degrees in the 0 to 360 range. To find this, we would take 405 and we would subtract 360 degrees from it until we got an angle that was in the 0 to 360 degree range. For this problem, subtracting 360 from 405 gives me 45 degrees, which is in my 0 to 360 range, and now I can try to work with this to figure out what the reference angle is. For 45 degrees, the reference angle for a 45 degree angle is 45 degrees, because we are 45 degrees away from the x-axis. We also are going to need to know what is the value of sine in each of the quadrants. For this problem, because my 405 degree angle, which is similar to the 45 degree angle, is in the first quadrant, the value of sine is positive in quadrant 1. To answer this problem now, we can now convert the 405 degrees into positive sine of 45 degrees. The sine comes from Q1, where sine is positive, and the 45 degrees is the reference angle. The sine of 45 degrees is square root of 2 over 2. That is found from our 45, 45, 90 triangle. Sine is opposite over hypotenuse, so the sine of 45 degrees, the side opposite of it is square root of 2 over 2, divided by a hypotenuse of 1, and therefore our answer for sine 45 is square root of 2 over 2. So the sine of 405 degrees, which is the same thing as positive sine 45 degrees, is square root of 2 divided by 2.
Here's another problem. Cosine of negative 750 degrees. We need to convert negative 750 degrees to an angle between 0 and 360. Since we're in the negative range, we're going to add 360 several times until we get an angle that lands between 0 and 360. Adding 360 to negative 750, we get negative 390 degrees. Adding another 360 to negative 390 degrees gives us negative 30 degrees. And adding a third 360 degrees to negative 30 degrees, we get 330 degrees. 330 degrees on our Cartesian coordinate plane is in the fourth quadrant. Because it's in the fourth quadrant, cosine will take on a positive value in the fourth quadrant, and the reference angle, how far it is from the x-axis, is 30 degrees. So we can now change cosine of negative 750 degrees into positive cosine of 30. Because cosine is positive in quadrant 4, and the reference angle for negative 750 is 30 degrees. Now we can find the cosine of 30 degrees, which is square root of 3 over 2, from our triangle. From our 30, 60, 90 triangle, cosine of 30 degrees is the adjacent side over the hypotenuse of 1, and therefore cosine of 30 degrees is square root of 3 over 2. Thus our final answer for the problem, cosine of negative 750 degrees, which is cosine of 30 degrees, is square root of 3 over 2. Thank you for watching Convert to Radians, a Pemberton Pre-Calculus podcast. This has been episode number 2. Stay tuned for another future episode which highlights things that you need to know and memorize for future quizzes. Thank you.